Another fundamental reaction of an alkene is the addition of HBr to an alkene with peroxide present. As you can see here, instead of the normal Markovnikov addition, we get the bromine at the least substituted position, which is known as anti-Markovnikov addition. And this is because of the peroxide present. Because instead of going through that normal carbocation mechanism, it goes through a radical mechanism, which leads to the regiochemistry. So we have our general peroxide right here, ROOR, and that's going to split up into peroxide radicals. Peroxide radicals? Anyway. So we're going to have that. We're going to have this right here with a dot. We have our HBr. And what's going to happen is this radical electron is going to come and form a bond with one electron from the bond. And then we're going to put one electron on the bromine. So we're going to get a bromine radical over here. And then we're going to have an alcohol, generic alcohol. So that's going to then react with our alkene. We're going to take one of our alkene electrons and form a bond. And the other one has to go into one of these carbons. It's going to go into the most substituted carbon. So we're going to get a radical that looks like this, where our radical is at that most substituted position and the bromine is at the least substituted position. Okay, and that's because the radical is, well, it's more stable at that most subsidized position. Then, what's going to happen? We're going to have another HBr. I'm going to do this all over again. We're going to take our radical electron, and we're going to form a bond with one electron from here, kicking one up there. And that's going to give us our product, and we're going to have a bromine radical left over. And that's what gives us the anti-Markovnikov addition with the bromine at the least substituted position.